This lesson, we're going to learn how to use log to do the differentiation and how to differentiate logarithm function. Before we learn the differentiation, we had to recall some properties of log. So the first four is called the basic properties, and property number 5 is actually called product property, and property 6 is quotient property, and property 7 is called power property, and 8 and 9 is called the change of the base property. Now, let's learn the differentiation rules for log. So whenever your function has a log x, log means log base e, then your differentiation will be put the x in the denominator, differentiation of the x, which is 1, put on the numerator. If you have log gx as your original function, then your differentiation will be put the gx in the denominator, differentiation of gx is going to be on the numerator. The next two is when the base is not e anymore, as any other constant, then you can do is put the x in the denominator, differentiation of x is in the numerator. It's similar to the first one. However, now you have to times by log of the base in the denominator. Now, next one, if you have log base b, gx, once again, the differentiation will be put the gx in the denominator, differentiation gx goes on the numerator. Because it's not base e, so we have to times log of the base called log b in the denominator. Now, let's take a look at example 1. We need to find dy over dx, which means we need to find y prime for the following functions. So part A, the function is in terms of log. So all we need to do is put the function in the denominator, and differentiation function goes on the numerator, which is going to be a 5. And let's reduce the 5, so your differentiation will be 1 over x. For part B, the function is still in terms of log again. So y prime will be put the entire function in the denominator, and differentiation function goes on the numerator. So differentiation x squared will be 2x, and differentiation e to the power x will be e to the power x. For part C, since there's a fraction, so we're going to use quotient rule. So we're going to write y prime equals to denominator square, which is x to the power 4, and numerator differentiation will be, because there's a log, so we put the x in the denominator, and differentiation x goes on numerator, which is 1, times by the denominator, minus the numerator, times by the differentiation denominator, and then we're going to simplify it. 1 over x times by x squared will become x minus 2x log x, x to the power 4. And let's common factor the numerator. So you have x in common, so left with 1 minus 2 log x divided by x to the power 4. And now we can simplify by dividing by x. And remember to write down restrictions. So y prime will be 1 minus 2 log x over x to the power 3. Example number 2, we need to find equation of the tangent line. That means we need to find the slope, which is y prime. So y prime equals to denominator square and differentiation numerator. So because there's a log, so we put the function in the denominator, and differentiation of the function x squared goes on the numerator, which is 2x, times by the denominator, minus the numerator, which is log x squared, times by differentiation of the denominator, which is 3. Next, let's simplify the numerator. So denominator will be 9x squared. So x times by x will be x squared, can divide it by this. So you have a 6 left, minus 3 log x squared. And then you can see they have a 3 in common, so factor out the 3. divided by 3 on both the numerator and denominator. Now, let's substitute x equals to 1 to find the slope. So 2 minus ln 1 over 3 times by 1 squared will be 3. And ln 1 is going to be 0, so we know slope is 2 over 3. So now we have the x, we have the slope, now we have to find y. So substitute x equals to 1 into the function to find the y value. So that becomes y equals to ln 1 squared, which is ln 1, over 3 times by 1 will be 3. But ln 1 is 0, so 0 divided by 3 would be 0. Finally, we can find the equation now. So let's find the equation now. We use m equals to y minus y1 over x minus x1. This will give us a standard form right away. So 2 over 3 equals to y minus 0 over x minus 1. And let's do a cross multiplication. You get 2x minus 2 equals to 3y. So 2x minus 3y minus 2 equals 0. And this is our equation of the tangent line in standard form. For this example, we are finding the value of the x at the point on the graph such that it minimizes the function. So the first thing is we want to get rid of the radicals so we can differentiate. And next, we do y prime. It will be bring down exponent take away 1 because that's a power rule. Next one will be the log rules. And because there's a ln, so we put the x in the denominator, differentiate x, put on the numerator, which is a 1. Next, we're going to common factor it to simplify this y prime. Since we are looking at the value that minimizes the function, that means we're looking for the minimum point. At the minimum point, the slope of a tangent line will be 0. So we are going to let y prime to be 0 to find the critical point. So 0 will be half. X to the power negative 1 will be 1 over x. X to the power half will be square root of x. And that means 0 equals a half, which is impossible, or 0 equals 1 over x, which is also invalid. Or square root of x minus 2 will be 0, means square root of x will be 2. By squaring both sides, we'll be able to remove the square root, so x will be 4. Now we know there is a critical point at x equals to 4, but we also need to identify what kind of critical point do we have. First, we draw a number line that represents the y prime. Next, we put all the critical points and restrictions on the number line. From the function, we already know x can only be greater than 0. So let's put 0 here, and that's an empty dot. And there is a critical point 4 right here. Then we're going to choose a value between 0 and 4, substituting into y prime to see that's positive or negative. So if you put 3 in there, you will see the y prime will be negative. And let's try 5 on the other side of the 4. And when we put it in, y prime is positive. So that means I know on the left-hand side of 4, the function is decreasing. On the right-hand side of the 4 is increasing. So this is actually a local minimum. Since the question didn't ask us to find the y values, to find the minimum y value, so x equals to 4 will be your final answer. Now, I verified it with the graphing calculators. I graphed the function square root of x minus ln x on the graphing calculators, and I asked the graphing calculators to give me the minimum point, which is going to be here. That, as you can see, the x value is 4. And you will see the function will never cross over the y-axis. That means the domain will be x greater than 0. And if you want to know why the domain has to be greater than 0, it's because, first of all, the value inside the square root can only be positive or 0. At the same time, the value inside the ln can never be 0 or negative. That's why the domain is x greater than 0. Now we're going to combine all the different types of functions together, and we're going to find the differentiation. For example number 1, when I look at the fx function, I see the base is a constant and the variable is in the exponent. That means this is exponential function, so we're going to use exponential function rule. So f prime will be copy down the function times by differentiation of the exponent times by ln of the base, which is ln 3. For example number 2, we can see g function is actually a product of two functions, so we're going to use product rule. So let's define our u and v. Our u will be x to the power 3, so u prime will be 3x squared. And our v will be the log function. And when I see square root, I will bring it up to the exponential form, which means half. And using property of log, I can bring the half down in front of the log. And then I will differentiate it. So whenever you differentiate a log, this function, x squared plus 4, goes into the denominator. And differentiation of this goes on the numerator, which is 2x. But since the base here, it's not e, it's 2, so we have to times by ln 2 in the denominator. Next, we're going to simplify it by reduce the 2 from both numerator and denominator. And then now we can find our g prime. By using the product rule, we know g prime will be u prime times by v plus u v prime. Once again, I can pull this exponent in front of the log, which becomes a coefficient. So I'm going to do 3 times by half will be 3 over 2. Combine the numerator, so x to the power 4. And then we're going to substitute 2 into the x. Now let's reduce the fraction. Log base 2a means 2 to the exponent something equals to a. The exponent is 3, so that will become a 3. So our final answer will be 18 plus 2 over ln 2. Example number 3, we will need to use implicit differentiation. So it was talking about the loudness of a sound is being measured by the equation loudness equals 10 log intensity over the reference intensity. So if the intensity of the siren is 7,000 units and increasing at a rate 100,000 units per unit, what is the accompanying rate of change of the loudness of the sound? First, we know this information here. That means change in the intensity over change in time will be 100,000 units per second. And it also talks about the intensity is actually 7,000 units. And we are looking for the rate of change of the loudness of the sound, means we are looking for change in the loudness over change in time, which is dL over dt. So now let's differentiate this function with respect to t. So differentiate L is 1 dL over dt equals to 10 is a coefficient. Now there's a log, so you put the entire function in the denominator, which is I over I naught. And differentiation of this function, it will go on the numerator. So now we need to see I over I naught really means 1 over I naught times by I. So the differentiation of this will be 1 over I naught, that's the coefficient, and differentiation I, which is 1, and di over dt. So now let's put the differential numerator on the top. And then we have to do ln of the base, which is 10. How do I know it's 10? If you don't see any base here, that means there's an invisible 10. Simplify further, you get dL over dt equals to 10, 1 over I naught, di over dt, over, I'm going to change this bracket into one term like 1 over I naught, the other term, I times by ln 10. So I can reduce them. And now let's substitute the value we know. So dL over dt equals to 10. di over dt is 100,000. Divided by I is 7,000. Ln 10. Then let's reduce the fraction by divided by 1,000 on both the numerator and denominator. Then we're going to get our exact answer. dL over dt equals 1,000 over 7 ln 10. And if you do on the calculator, you will see dL over dt is approximately 62 decibel per second. Sometimes using logarithm differentiation is necessary when you see the variable in both the base and the exponent. Because in this case, power rule wouldn't work and exponential function rules will not work either. So, the first thing we do is we are trying to get rid of the variable in both the base and exponent by taking ln on both sides. And using property of log, I can bring the exponent x down in front of the log. And then I can use implicit differentiation to differentiate the following. So ln y becomes 1 over y and dy over dx equals to, on the right hand side, that's a product rule. So this is our u, this is our v. So let's do u prime, which is 1 times by v ln x. plus u, which is x, times by v prime, which is 1 over x. So that's simplified it. It will become ln x plus 1. So our dy over dx will become y times ln x plus 1. And let's replace the y with x to the exponent x, ln x plus 1. That's our differentiation. Let's try again on example 2. So same thing again, they have variable in the base and the variable in exponent. So we need to use log to get rid of the variables in both the base and exponent. So let's take ln on both sides. And using property of the log, you can bring the exponent x down. And that's differentiated. So ln y, you put y in the denominator, differentiate y, 1 on the numerator, and this term is the y term. So we say dy over dx, which is, now, this is also a product rule. So differentiation of x, which is 1, times by ln x squared plus 3, plus x times by differentiation of the v, which is inside a log function. So you put the function in the denominator, and differentiation of this goes on the numerator. Now that's simplified it. And let's move the 1 over y to the other side. That means you're multiplying by y on both sides. Final step, let's switch our y back to x squared plus 3 to the exponent x times by ln x squared plus 3 plus 2x squared over x squared plus 3. And that's our differentiation. For this example, I want to show you how we use log to make a function very easy to differentiate. So obviously in this function here, you can use quotient rule, and inside the quotient rule, there is a product rule. Inside the product rule, there's a chain rule. So the differentiation will become very complicated. However, let's try a different way. We're going to use log to help us to find the differentiation. So let's take ln on both sides. And using property of log, I know when you are multiplying means you are adding 2 log together. And when you are dividing means you subtract the log. Next, let's simplify further by moving the exponent down in front of the ln. And now we are ready to differentiate. So ln y is 1 over y dy over dx equals to, that's a ln, so you put the function in the denominator. Differentiation of the function here goes on the numerator, which is 4x cubed. Plus half is the coefficient times by, put x plus 2 in the denominator. Differentiation of x plus 2 goes on the numerator, which is a 1, minus, you put 2x squared plus 2x plus 1 in the denominator, and differentiation of this goes on the numerator, which is 4x plus 2. Usually at this step, you will be able to substitute x equals -1 into the equation here to find the slope of tangent. But the only problem we have here now is we have a 1 over y on the left-hand side. That means not only I need to know the x value, I also need to know what's the y value. So we have to put x equals negative 1 into the original function to find y. So at x equals negative 1, your y is going to be negative 1 to the power 4 will be 1. 1 plus 1 will be 2. And square root of negative 1 plus 2 will be square root of 1, which is 1. And 2 times by 1 will be 2, minus 2 plus 1 will be a 1. So my y value is 2. So that's substitute x equals negative 1, y equals to 2 to find dy over dx. Negative 4 divided by 2, negative 2, plus half, plus 2, because this is negative 2 will become positive 2. So 1 over 2 dy over dx will become half. Multiply by 2 on both sides. I know the rate of change is going to be 1.